section 4.3 in our current textbook, but it's basically solving quadratic equations by factoring. Couple vocabulary terms here. We have a monomial, which is a single term, such as x, x squared, 1, 3. That's a monomial. A binomial would be two terms, x plus 3, x minus 2, that's a binomial. X squared minus 7, that's a binomial. And then a trinomial has three terms. Main thing here that people forget about all the time is that terms are separated by addition and subtraction. Factors are separated by multiplication. So this 7 is not considered its own term because it's being multiplied by the x. But 7x is considered a term. Okay? When we factor a quadratic trinomial or binomial, because we're going to see both of those, if it is possible to factor, it will most likely factor to a product of binomials, almost always. Unless the only thing you can factor is the greatest common factor. That is the first step with all factoring. It's not really going to apply that much today, but for the future it will. Okay, but the first step in factoring, which is often forgotten, is to always look for the greatest common factor of the terms. Alright, let's just jump into this factoring business. Okay, first we're going to test to see if it can factor, then we will factor if it can. To test if something can factor, you multiply the first times the last terms. Alright, x squared times 18 is 18x squared. And then you think about, alright, are there factors of 18 that will subtract to 3? Oh yeah, 6 and 3. 6 minus 3 is 3. So this will factor. So we set up our binomials. Okay. We're going to have, since all of them are going to start with x squared or n squared or b squared or whatever, they will all have an x here and an x here. Now, since the third term is being subtracted, that means that one of these is a plus and one is a minus. So we have a positive and a negative. Now you got to think we've got a negative 3 here, so that means that the 6 is negative and the 3 is positive, because negative 6 and 3 is negative 3. Okay. Another way to do that, my factors, 18x, we've got 6 and 3. I subtracted. Now the larger of these two is going to get this symbol here. Okay. The next couple we'll do that way. Next thing, part B, x squared minus 3x plus 9. Test to see if it'll factor. Multiply x times 9, so we got 9x squared. Now, are there factors of 9 that'll add to 3? The factors of 9 are 1 and 9 and 3 and 3. None of them you can add to get 3, so this one cannot be factored. Okay, so that's what'll happen when you get one that cannot factor. Next one, multiply the first and the last term, so we've got 63x squared. Now think, we want factors of 63 that will subtract to 2. First ones that come to mind are 7 and 9 for me, so 7 and 9. Now here, this third term's being subtracted, so I'm going to have opposite signs here. The 9 is greater than 7, so the 9 is going to get the plus, and the 7 is going to get the minus. And these are basically going to be your factors. We're going to have x minus 7 and x plus 9. And to check it, do your outers and your inners. I got 9x plus negative 7x is 2x. Okay. Now we have some special factoring patterns. Okay? Some special factoring patterns. We've got the difference of two perfect squares. This is going to be a quadratic binomial. It's going to have two terms in it. They're going to be subtracted. That's the difference. Okay? This will factor to a product of binomials. Okay, notice here we got a squared minus b squared. It's going to factor to a plus b times a minus b. An example of this would be x squared minus 4. That's going to factor to x plus 2 times x minus 2. If you memorize these special factoring patterns, it'll make things go so much quicker for you. Perfect square trinomials. Okay, like with numbers, we have perfect squares, perfect cubes. Perfect square trinomials will look like this. A squared plus 2 times AB plus B squared. Okay, when you're looking at an actual one, you want to decide if it's a perfect square. Start by looking at the first and last term. First term's x squared. Yep, that's perfect square. 64. Yep, that's 8 squared. Okay, so the middle term, this should be 16. I just found that mistake out because it's 8 squared. It's 2 times a times b, so that should be 16. Let's make that correction right now. And this should be 8 here. Yay, I love making mistakes. So that way we've got x squared and 64. 64 is 8 squared. X squared is x squared. 2 times x times 8 is 16x. That's the middle term. Okay, next one, we've got, this time the middle term is being subtracted, so it's a minus b squared is what it'll factor to. X squared minus 14x plus 49. Okay, this is where knowing your perfect squares comes in handy. X squared is a perfect square. 49 is a perfect square. It's 7 squared. Well, so that's the first clue that you look for to see if it's a perfect square trinomial. And then you take the square root of both of these and multiply it by 2. Oh, square root of 49 is 7 times 2 is 14. Oh, 14x. Looky there, I got a perfect square trinomial. It'll factor to a minus b, square root of this minus the square root of that squared. Okay. Here I've got two terms subtracting. It's the difference of two perfect squares. X squared is a perfect square. 100 is a perfect square. Okay, so it's going to factor to something plus something minus. X plus 10, x minus 10. Okay, if you can't remember that, then the other thing you can do is do x squared plus 0x minus 100. Yep, minus 100. You can throw that extra term in there, find the factors of 10 that'll subtract to 0, and that's how you go about that one. Okay. Here's another one. You can always do the test to see if it'll factor, but I like to look and I say, oh, 81's 9 squared. X squared is x squared. So this is a perfect square trinomial. This one's going to factor to x minus 9 squared. Okay. The other way to do this is just do like we do all the others. 81 times x is 81x squared. Factors of 81 that'll add to 18. Oh, 9 and 9. 9 plus 9 is 18. Okay. And then you're going to have x minus 9 times x minus 9, which is x minus 9 squared. Why do we do all of this? Well, we do all of this because we are going to try to solve these equations. And it's easier to solve by factoring than it is by any other method. Especially if you know your multiplication facts, because then you can factor very quickly. Because we're going to use the zero product property. If a and b are expressions and a times b equals 0, then either a equals 0 or b equals 0. So one of them has to equal 0. So if you can factor something and that thing equals 0, one of them equals 0. Okay, when we're solving, we're finding, and you'll see this, you'll hear me say this over and over again, When we solve, they are the solutions to the equations, they are the roots of the functions, and they're the zeros of the graph. Okay, so factors, zeros, factors, roots, they all have some kind of something in common. So we start by factoring or testing to see if it'll factor. 36 times x is 36x squared. What are the factors of 36 that'll subtract to 5? Oh, 9 times 4. 9 and 4 will subtract to 5. Now 9 is greater than 4, so the 9 is going to get this sign. Oh, so that means x minus 9, x plus 4 equals 0. Now, if you get to the point where you don't have to do this to do your factoring, that's great. By all means, do that. Save yourself some time. Now, set each factor equal to the 0, and those are the solutions to the equation. X minus 9 equals 0. X plus 4 equals 0. Most of you can do this in your head, so x equals 9. X equals negative 4. Okay. To check your answer, you plug them in, and they will both work. Okay. Next one, 42. What are the factors of 42 that will subtract to 1? All right, 42x squared. We've got 7 times 6. Those will subtract to 1. 7 is the greater, so 7 gets this sign. So 7 is going to get the negative, and 6 is going to be positive. When it factors, we're going to have x minus 7, x plus 6 equals 0. Set each factor equal to 0. X minus 7 equals 0. X plus 6 equals 0. So x equals 7 and x equals negative 6. We'll use this to find the zeros of the functions. Okay, remember, factors, solutions, zeros, roots, they're all pretty much different names for the same things, same numbers, just different names for them. So to find the zeros of the functions, that means we're going to set the function equal to 0 and solve. So it's going to be x squared minus x minus 12 equals 0. Set the function equal to 0. Now solve. So we're going to factor. Okay. Now I hope by now you can probably do this. So x, this is going to be x plus something, x minus something. What are the factors of 12 that'll subtract to 1? Well, 4 and 3. 4 is greater than 3, so 4 is going to get the minus. So the 4 is going to go here, the 3 is going to go here. Check it. Negative 4 plus 3, negative 1. X plus 3 equals 0, x minus 4 equals 0. So x equals negative 3 and x equals 4. Those are the zeros of the function. That means if I plug these into this function, the answer is 0. Find the zeros of this function. Okay, we're going to say 0 equals x squared plus 12x plus 36. Okay, hopefully something's ringing a bell for you because x squared is a perfect square and 6 squared is 36. So perfect square trinomial. Okay, so 0 equals x plus 6 squared. Okay, those special factoring patterns will help you in the long run. So that just means I've got one factor. Technically there's 2, but only one number is going to be a 0 to this function. So x plus 6 equals 0, so x equals negative 6. This function only has one 0. I just threw this in there because you might see something in your textbook. Factored form is also called intercept form because when we get to the point where we're going to graph these, if you can factor it, those factors are giving you the x-intercepts of the graph. There's another one for you.